This is lesson 2.1, Write Conditional Statements, Converses, and Counterexamples. Now, this is the beginning of chapter 2 called Proofs and Reasoning. And in this unit, we're going to do a lot of, creating logical arguments, taking some information that we're given and making a logical conclusion from it. And to get us started with that, we need to talk about conditional statements. Here's the thing, you already hear conditional statements all the time. This might be at home, this could be at school. Here's an example of a conditional situation right here. So this young man says, "Can I go to the movies tonight?" And his mom says, "Only if you do the dishes." That is a conditional statement. There's a condition to the conclusion coming true or happening. So yeah, you can go to the movies, but first this condition has to be met. You have to do the dishes. So that is a conditional statement. A conditional statement is a logical statement that has two parts. One is the hypothesis, and then one is the conclusion. I'm going to use red highlighting when I talk about the hypothesis, and I'm going to use blue highlighting when I talk about the conclusion. So here is that same statement. If you do the dishes, then you can go to the movies tonight. Our hypothesis is that you do the dishes. That is the condition that needs to be met in order for the conclusion, you can go to the movies tonight, to follow. Okay, so hypothesis and conclusion. So many times our conditional statements will be written in this format called if-then form. If the hypothesis is met, then the conclusion will follow. But not all of them are written in if-then form. Sometimes it might be written like this. Again, something you might hear at home. You can only go to the mall if you finish your homework. Okay, so let's think about where is our condition that has to be met in this statement. Well, it comes after the conclusion in this case. So here it is. Oops, I'm not going to use that color here. Hold on. Here we go. So you finish your homework is our condition. That has to be met before you can go to the mall, right? So if we were going to write this in if-then form, we're actually going to include this part first as our hypothesis. If you finish your homework, then you can go to the mall. If you finish your homework, then you can go to the mall. Now, as we're going to find out, sometimes conditional statements are true, but sometimes they're not true. So let's take a look at some examples. So let's take a look at some examples of rewriting a statement in if-then form. So this first example says all triangles have three sides. So if we think about the hypothesis in this situation, the condition that's met, that is that we have a triangle. And then what happens if we have a triangle? Well, then it has to have three sides. So if we were going to rewrite this, we would say if a figure is a triangle. So notice that I changed some of the wording of the situation to make it make sense. So in geometry, we talk about figures, right? Points, lines, planes, segments, all sorts of things that we are learning about. So if a figure is a triangle, then what? Well, then it has three sides. All right, how about a number is divisible by 2 if it's even? Now, if you listen to that kind of carefully when I read it, you might have noticed this little word if right here. If is in the middle of this sentence, which actually gives us a clue that we want to start with what comes after if, because that is the condition, right? So a number is divisible by 2 if it is even. So we have our hypothesis over here, a number is even. And then what is true, what conclusion is following that hypothesis or that condition is that it is divisible by 2. So if we rewrite that one, we should write if a number is even. We wouldn't want to say if it's even. It sounds a little funny. So if a number is even, then what? Well, then it is divisible by 2. Okay, so now let's take a look at this statement right here before we look at the word counterexample. It says, if you pass the test, then your grade is a B. Well, we all know that that's not true. There are people who pass tests who don't earn a B on the test. They earn an A or a C, and they still pass the test. So here's the deal. Sometimes conditional statements are false. And when they are false, we need to supply a specific example that shows that it's false. And that is what we call a counterexample. It's an example that shows that something's false. So if you pass the test, then your grade is a B, is false. I'll just write an F here for false. And a counterexample would be this. A specific example, so I'm just talking about Luna. I just came up with a person. Luna passed the test. So my hypothesis is true. My condition is met, but she got an A. She passed the test with an A, so then my conclusion does not follow. Pass the test, but not with a B. That is a specific example that shows that that statement was false. Now, the second one, if an angle is obtuse, then it is 130 degrees. Well, that's also false, right? Because we can have an obtuse angle, and yet the conclusion does not follow. It doesn't have to be 130 degrees. So a specific example might be an obtuse 120 degree angle. So it's obtuse, the condition is met, but the conclusion does not follow. It's not 130 degrees, it's 120. Okay, so take a minute, pause the video, and try these examples and see after you restart the video how you did on these counter examples. All right, so the first one, number one says, if an angle is acute, then it measures 34 degrees. So again, our hypothesis, an angle is acute. Our conclusion, it measures 34 degrees. That's false, right? There is an acute angle out there that is not 34 degrees. Which one of these is our counterexample? Okay, hopefully you said D. A 35-degree angle is acute, but it doesn't measure 34 degrees. The next one. Okay, if an animal has 4 legs, an animal has 4 legs is our hypothesis. It's a condition we have. So there's an animal in front of us that has 4 legs. The conclusion says, then it is a dog. Well, guess what? That's not necessarily true. If we can provide an example of an animal with 4 legs that's not a dog, we are good to go. And we can do that because right here, a horse has 4 legs, but it is not a dog. Okay, hypothesis is met, conclusion is not. How about the next two? Provide a counterexample. This one says, if a figure has more than 2 sides, then it is a triangle. Well, again, if we have a figure with more than 2 sides, we have to provide an example that is not a triangle. Well, if you said rectangle, oops, my pen is a little strange here. If you said rectangle, that would be a fine counterexample. So I have a figure that has more than 2 sides, a rectangle, but it is not a triangle. And the last one on this page, if there are 2 odd numbers, then their product is less than 17. Okay, so hypothesis, there are 2 odd numbers. We have to have a condition that, or a hypothesis, an example that makes that true, but the product is not less than 17. Can we do that? Sure. So perhaps you came up with your own 2 odd numbers, but let's say I chose 3 and 11. So are those 2 odd numbers? They sure are. Is their product less than 17? Well, no, because product means multiplication. And if I multiply 3 and 11, I get 33 for my product, which is not less than 17. So hopefully you notice that what happens in a counterexample, it's very clear. For a counterexample to work, the condition, the hypothesis has to be true, 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 and true. But then your example does not meet the conclusion. That's what's going on in all 4 of these counterexamples. Okay, so one more new term for you today is converse. Now, what the converse is of a conditional statement is simply a new if-then statement that switches the order of our hypothesis and our conclusion. That is what a converse is. So if you're asked to write a converse, you take what would originally be the hypothesis and you move it to where the conclusion goes, and you take the conclusion and you move it where the hypothesis was. So write the converse, tell whether it's true or false, and if it's false, provide a counterexample. Well, here is a similar problem or similar statement that we've had today. If you got an A, then you passed the test. So as we've been doing, I'm going to use red here for my hypothesis. You got an A. That's our hypothesis. And then if that's true, then you pass the test. Now, is this a true or false conditional statement? If you got an A, then you pass the test. Well, that's true. If you got an A on the test, then you passed it. So the converse means that we're going to switch this and this around. So we're going to move this you passed the test to the front, and we're going to move the you got an A to the back. So if you passed the test, and now that's the hypothesis, so it's red, then you got an A. So we switched our conditional statement to the converse, and now our hypothesis is this. If you pass the test, then you got an A. Now, is our converse true or false? Well, our converse is false. Okay? Because if you pass the test, you might have got a B. So again, we use a nice clear counterexample. I passed the test, but with a B. Now let's do one more of these. It's not in your notes, but I'm going to ask you to think about the statement. If two angles are vertical angles. Okay, we learned about vertical angles recently. And what do we know if two angles are vertical angles? Well, we know that they are congruent, right? So then they are congruent. What would the what would the converse be? Well, we're going to move our hypothesis over to here, and we're going to move our conclusion over to here. So it would be if, I'm going to move my arrows with it. It's fine, right? If two angles are congruent, then what? Well, then they are vertical angles. What do you think about that one? True or false? If two angles are congruent, then they are vertical angles. Well, that is false. And a counterexample sometimes is a picture. So here's a picture of two angles that meet the condition. The two angles are congruent, but the conclusion does not follow. They are not vertical angles. They are not connected at their vertex. So a lot of what we're going to be doing is writing if-then statements, talking about whether they're true or false, writing their converse, telling if those are true or false, and providing counterexamples when things are indeed false. Okay, feel free to try these on your own and then check back to see how you did, or you can follow along if you're not ready for that. So, first of all, points are labeled with a capital letter. Okay, it is a conditional statement, but we are going to write it in if-then form. So we are talking about points. So we're going to use that as our hypothesis, that we have a point. And it's labeled with a capital letter, and that is true. We know that. But first, let's write it in if-then form, right? If we have a figure that is a point, right? So if a figure is a point, then it is labeled with a capital letter. Now, if we switch our hypothesis and conclusion, then we get our converse. If a figure is labeled with a capital letter, then it is a point. Now, that is false. And maybe you can think of an example of why that's false. Here is one. What if I have a plane and I put a capital G in the corner? It is labeled with a capital letter, and it is labeling a plane. All right, the last one here. Adjacent angles share a common ray. So if two angles are adjacent angles, then we know they're going to share a common ray. And we can write that as I said it just a second ago. If two angles are adjacent, then they share a common ray. The converse, if two angles share a common ray, then they are adjacent. And that is true. All right, more practice in class and online.